The general matrix for a 6 comma 3 linear 4 over GFT is given by G is equal to like that. The G is the form is G is equal to I T or Pi. See, this one generator matrix is entirely different. It is not these two forms. It is not in these two forms. Therefore, G is called as G is in non-systematic. Non-systematic. First one need to be determined is X plus G is in systematic form. Second one is find the code word with 110 as information bits. This is the 6 comma 3. K is equal to 3. 3 information bits are there. Each and every message contains 3 information bits. Find the code word with 110 as information bits. By using both G is in systematic form and G is in non-systematic form. Third one is list the code words generated by the matrix in both systematic and non-systematic form. Fourth one is construct an encoder for 6 comma 3 4. These are the first one. Calculate the first one. Express G is in systematic form. GS is equal to IK comma P, where K is called as identity matrix. This one is 6 comma 3 linear block code. N is equal to 6, K is equal to 3. 3 by 3 identity matrix 1 0 0 0 1 0 0 0 1. This is the identity matrix. This is G is in non-systematic form. This non-systematic form is converted into systematic form, performing row operations. First row operation is like that. Interchange R1 and R2. R1 is replaced with R2 row, that is 1 1 0 0 1 1 1 0 0 1. R2 is replaced with 0 1 1 0 1 0 0 1 1 0 1 0. R3 as it is, that is 1 1 0 1 1 0. First row operation is completed. Second one is R3 is equal to R3 plus R1. R2 is as it is. R1 is also as it is. R3 need to be changes. R3 is equal to R3 plus R1. One exclusive R with 1 is 0. One exclusive R with 1 is 0. 0 exclusive R with 0 is 0. 0 exclusive R with 1 is 1. 0 exclusive R with 1 is 1. 1 exclusive R with 1 is 1, like that. Step 3. R1 is equal to R1 plus R2. R1 is equal to these two rows are same. 0 1 1 0 1 0 0 1 1 0 1 0 0 0 1 1. R1 is changed to R1 is equal to R1 plus R2. 1 plus 0 1. 1 plus 1 plus 0 is 1. 1 exclusive R with 1 is 0. 0 exclusive R with 1. 0 0 0 1 1 1 0 1. This is the 1 0 0 0 1 0 0 0 1. Here required our requirement is like that. Last column here 1 1 0. This one is fourth column. This is the third column. This is the fourth column. Third column and the fourth column is needs to be interchanged. That is 1 0 0 0 1 0 0 0 1. The third column is placed to fourth one. Fourth is placed to third one. Third one is placed to fourth one and 1 1 0 1 1 0 1 1 1 1 0 1. Therefore, this is G is in systematic form. 1 0 0 0 1 0 0 0 1. Like that. Next one, find out the code word information bits in systematic form using systematic generator matrix. Find out X coded word. 1 is multiplied with first row, as it is, 1 is multiplied with second row as it is, 0 is multiplied with all zeros, perform exclusive OR operations. This is the code word, encoded code word. This is obtained by using systematic generator matrix. Non-systematic generator matrix. This is the given one is non-systematic generator matrix 1 1 0. 1 is multiplied with first row as it is. 1 is multiplied with second row as it is. 0 is multiplied with third row. That means all zeros. Perform exclusive OR operations 1 0 1 0 1 1. 1 1 0 is not appeared at the beginning. Generally, in systematic, message bits are appeared first and followed by parity check bits. Here 1 1 0 is not there. In previous case, in systematic code word, the systematic encoding case, 1 1 0 is appeared at the beginning. Third one, code word generated by the matrix in systematic form. K is equal to 3. Total 8 information 2 cube. That is equal to 1 2 3 4 5 6 7 8. 8 possible message vectors are there. These message vectors are multiplied with the systematic form of generator matrix. We will get 8 encoded code vectors by using systematic generator matrix. X5, X6, and X7. 1 is multiplied with first row as it is. 1 is multiplied with second row as it is. 1 is multiplied with third row is as it is. Perform exclusive OR operation, we will get this encoded code word by using systematic form of generator matrix. Next, code words generated by the non-systematic form. Given generator matrix is non-systematic form, here uses as it is. Again, A is equal to 3, 4, 8, 2 cube, that is 2 cube, 8 possible message vectors are there. These possible message vectors are multiplied with non-systematic form of generator matrix. We will get encoded code vectors, which are not in systematic form. These are non-systematic form. Because 100 is there, 100 is not appear at the beginning. That is, this code word belongs to non-systematic form. Last one is construct an encoder for a 6,3 code. Consider a systematic form. C is equal to MP. C is called as parity bits. M is the message vector. C is the parity vector. M is the message vector. P is a sub-parity matrix. The dimensions are like that: 1 cross Q, 1 cross K, K cross Q. Here C1, C2, C3, M1, M2, M3. See the P submatrix. In system, P submatrix is obtained from systematic form. P submatrix is obtained from systematic form. 1 1 1 1 1 1 0 0 1 0. See the P submatrix. 1 1 1 1 0 0 1 0. C1 is equal to M1 exclusive OR with M2 exclusive OR with M3 0. M3 is multiplied with 0, that is 0. Next one, M1 exclusive OR with M2 exclusive OR with M3. C3 is M3. Information bits. M is placed here. These are the flip-flops we use it to store the message bits. 3 message bits are there: M1, M2, M3. Find out C1. C1 is equal to C1 is determined from M1 exclusive OR with M2. M1, this is 1 M1, this is M2. M1 exclusive OR with M2. C2 is M1 exclusive OR with M2 exclusive OR with M3. M1, M2, M3. C3 is only M3. These are the parity bits, check bits. Information bits are applied to the switch. Parity bits are also applied here. Therefore, code word consists of message bits followed by check bits. For every message bit, need to be calculated this entire code one. This is the construction of an encoder. Encoder gives encoded code word. The encoded code word is in the form X is equal to M1, M2, M3, C1, C2, C3. With this, the explanation is completed.